Hi everyone, I'm Jim White. In a previous video that was titled Aircrete Experiments Part 2, I first showed this foam generator, and several people have asked for more details about it. In a video titled This Really Sucks, I showed how to build the eductor, which is part of the foam generator. So I have links to both those videos below. But basically, it's made out of 2.5-inch PVC pipe, and this is about 36 inches tall and holds about a half a gallon of solution. And I cut the pipe purposely and put a coupling here so that these brackets would be straight up and down instead of tilting in at an angle. And this is CPVC pipe, and that picks up the foam solution in the bottom here. There's just a right angle fitting with a short piece of pipe in it, and then I drilled a 5/8 inch hole through this pipe cap and the tubing, and with adhesive affixed this assembly to the main tank. Up here we have a needle valve for adjusting the flow rate of the foam solution in the airstream. And here's the eductor that I was talking about. And then I have a pressure regulator here. This is one I had on hand, but you can get one at Harbor Freight to serve the same function. And the gauge can be mounted on either side depending on which way you want the flow to go. So let's put this thing on the floor next, and I'll show you more details really about what's inside at the top. Okay, we're looking at the top of the foam generator. Let's take the cap off. And this is a 1/4 inch NPT pipe nipple. And remember, pipe goes by the inside diameter. So this was about a 7/16 inch hole that I drilled and then tapped for the pipe. And pipe taps are kind of hard to find. This is a set that I got at Harbor Freight. I think it was around 15 bucks. Normally you'd pay 15 bucks just for the tap. So working with plastic, this should be just fine. So this has 3 different sizes, and the smallest size is a 1/4 NPT. NPT stands for National Pipe Thread, which is a taper thread rather than a straight thread. Then, so this is where the air will come in, and on the other side we have the CPVC pipe. This is nominal 1/2 inch pipe, and that hole was a 5/8 inch hole, and then sanded or filed as needed to get a snug fit with a piece of this pipe on the end of the right angle fitting. And again, that was welded in with normal pipe adhesives. So then we come out here to a coupling, and into this end of the coupling I also cemented a piece of this pipe which I could then tap with the 1/4 inch NP tap so that it would take this fitting for the barbed hose. Come on, focus. There we go. So this is a barbed hose fitting for 1/4 inch inside diameter tubing or hose. And in order to make these connections to the compression fittings, I have a short piece of copper tubing in here, and it just looks like that. It's 1/4 inch OD, and I cut a piece off about a 1 1/4 inch long. A tubing fitting works real good for that. It kind of curls the edges over so there's no sharp edges. So at any rate, all these compression fittings are done to the copper tubing, and then the hose is stuck over the copper tubing and secured with hose clamps. So when the cap is on, this line is pressurized to the same pressure shown on the regulator gauge. So when we call for air by pushing on the valve on the wand, air will shoot through here, through the eductor this way, and suck the foam fluid that way. And it's possible to control the mix, how much foam liquid comes for a given amount of air with the needle valve. Now, needle valves are multi-turn valves. A plunger goes in and out of the hole slowly, so it's a variable orifice, and you can control the flow that way. Now, in the video titled "This Really Sucks," I show you how to make an eductor with some standard parts so you don't have to do any machining. My first version of the foam generator, I used silicone rubber tubing, and that stayed good on this part of the eductor. But when I went to the reinforced Tygon tubing, which is necessary for the pressures that you might get if you go above 35 psi, you want to use the reinforced Tygon tubing. The tubing just would keep slipping off of this. So I remade this using a piece of aluminum, and I'll show you how to do that if you don't have a lathe handy. By the way, the feet of the unit are standard shelf brackets for holding up shelving. Here's a shelf, and there you can see the that type of shelf bracket with the reinforcement arm going across. Okay, next let's talk about the foam wand. But first I want to clear up something. I said that the body of the foam generator was made out of 2.5 inch PVC pipe, but it's really only 2 inch. And I think I called this tubing cutter a tubing fitting or something. That's a tubing cutter. Okay, the wand is made out of 1.5 inch PVC pipe with these type of fittings on the ends where a cap can screw on. Now these are just different styles of the same type of fitting. In one of the caps I used a hole saw to drill a 1¼ inch hole. And you can see there's a piece of hardware cloth across the end of the cap inside to hold in the stainless steel wool. And hardware cloth looks like this, and you can just cut out a circle using wire cutters. Then this is a blow-off valve, which is often used just to blow compressed air on things. And this is a 1/4 inch NPT nipple. And here I've used a brass barbed hose fitting. It's a 1/4 NPT screwed into the valve body. And then there's a barb fitting here that's for 1/4 inch inside diameter hose. And you can use brass or plastic. I think for 20 or 30 cents more, the brass is a good buy. Up here I used the same thing in plastic. I would if I was rebuilding it, I'd probably use brass in both places. So after the hole is drilled and the hardware cloth is in place, then this is just stuffed with the fine stainless steel wool. And then this cap is tapped with our 1/4 inch NPT tap to take this 1/4 inch pipe nipple. And then everything can just be screwed together. So that's pretty much how the wand is made. And next, I guess we'll demonstrate this. And I'll show you how to control the mix for a wet or a dry foam. Okay, I've attached the foam generator to the air supply. And let's set the pressure to 30. There's 30 psi. And I have the needle valve fully closed, which is clockwise. So at this point, we should only blow air. So now let's open the needle valve, maybe a 1/4 turn. And there we're starting to get some foam. Now I'm going to turn the needle valve another 1/4 turn. And you see the consistency looks a little different. So let's go another 1/4 turn. And you can see it looks a little different. And we'll go another 1/4 turn. Looks about the same. We may be at the limit. Let's just go a whole nother turn and see what happens. Okay, I guess that's the maximum solution to air ratio there. And it's a wetter foam than what we started out with, but it still looks like a very nice thick foam to me. So let's take her up to 50 psi. Okay, let's close the needle valve and start over. Okay, we'll open her a half a turn. And you can see the foam looks a little different. So with this setup where we can adjust the pressure and the flow of liquid separately, you can adjust the quality of the foam for whatever you want to do. And I think you could weigh the foam to determine what's going on by putting the bucket on a scale and filling it with foam and weighing it. You can get a better idea of how much of the solution is mixed with the air. Okay, let's take our pressure up to 80 psi. And here you can see we have some small leaks which we'd have to fix if we want to run at these higher pressures. So that's the production rate at the higher pressures. And if you fixed all your leaks, you can probably go to 100. Now I'd like to warn you, if you go to larger tubing to make your reservoir hold more, look at the pressure ratings. PVC pipe pressure ratings go down as the size goes up, and also they degrade rapidly with temperature. If you're working outside on a hot summer day, the pressure rating can go down to a half or a third of its room temperature rating. So think about that if you want to make a bigger reservoir. Okay, here's one possible way to make a nozzle for our reductor. Here's a piece of the copper tubing, and here's some two-part epoxy, which we're going to mix up on this piece of plastic. And I'm going to use this piece of hose to hold the tubing, and by inserting it partially in here. And then with our mixing stick, we're going to work some epoxy partway into the end. You don't want to go very far, maybe a quarter of an inch or so. And then after the epoxy is set up, here's a piece of wood with some 1/4 inch hole drilled in it. and we'll put the piece of tubing with the epoxy in this end here, and then drill through the epoxy with a 1/16 inch drill. And that will make a nozzle that'll go into the T-fitting to make our eductor. I'm not going to show all the steps here. I'll show you the finished part when we're done. Okay, it's the next day and the epoxy seems hard. So now all we need to do is drill a 1/16 inch diameter hole through the epoxy. And I'll do that on the same drill press that I drilled the original hole in the wood, which should line the hole up with the axis of the tubing. The hole doesn't have to be exact center. It can be off center a little bit and things will still work fine. Just try to get it as close as you can. Okay, I drilled the hole as close to the center as I could. It looks pretty good. And when I was about halfway through, this started to spin on the drill. So I just grabbed it with a pair of pliers to hold it from spinning. So on some of the nuts for the T-fittings, the ferrule is loose, and on some it's captive in the nut. But at any rate, we need to slide the ferrule on the tube and into the nut and make sure this is hard up against the bottom. And then tighten this up with wrenches and you got an eductor, and that should really suck. Okay, there you have it. You should be able to build this foam generator after watching the video. And what follows is just more information on the parts. So have fun, good luck. Okay, here's the needle valve that we need. And there's the price. Okay, I'm here at Harbor Freight, and this tap and die set has a 1/4 NPT tap, and the set's only 15 bucks. So with this you can tap the tubing to attach the needle valve. Here's 1/4 inch OD copper tubing. Comes in a coil. And there's the price. Here's some items you'll need for the foam wand. This is the mesh that I used to keep the steel wool in the wand. And there's the part number. Here's the fine stainless steel pads that the wand is stuffed with. There's the part number. And then the valve to turn the foam on and off. There's the part number. And here's the prices. A 1 foot by 24 inch piece of the wire cloth is $1.69. 3 packs of the stainless steel bowl are $7, and the blow-off valve is $13. Here's galvanized 1/4-inch pipe nipples. They're on the bottom shelf here at Menards, and you can get them in various lengths, and as you can see, they're pretty cheap. Okay, here's the tubing you'll need. This is reinforced vinyl tubing, and it's a 1/4-inch inside diameter, 10 feet long, for $3.69. Here's the 1/4-inch inside diameter barb by 1/4 MIP, which is the same thing as NPT. And it's $1.09. Here's the same thing in brass for $1.47.